Okay, so the first step that we're going to be doing today is we're going to be selecting our function. So all of you are supposed to end up with different functions, or they'll be similar but slightly different, which means you need some rules for how you can select your function. So the first step is to select a value of a. Now, a in our sine or cosine graph, well, typically it's set out like this, y equals a, then you have a type. We're all going to be doing sine graphs for the first one. Bracket b, bracket x, plus c, bracket, bracket, plus d. So, one important thing to note is that this b is in front of that bracket in there. If you have it set up like bx plus c, then that will give you a different answer. So you need to make sure that this is set out in this form. Mr. Toon, if you don't start acting responsible, I will hurt you. Stop it! I'm not editing this video. It's going up as is. Okay, so selecting our value of a. Now, you can choose, I would recommend either the number 1, 2, or 3. Any of those will be fine. For our value of b, I'd like you to choose either 1 or 2. For our value of c, which will be our phase shift, you can choose to have it either a positive or negative, pi on 2, pi on 3, or pi on 4. We're selecting these values because it will work out nicely for us later. And the effect that b has on the graph is that it will affect how long it takes for your function to do one period, which is from where it starts to the max, to the min, back to where it started. Okay, and luckily last, d is our equilibrium value. So that is where the middle of this function is going to occur. Now you could choose for that to be at -2, +2, 1, -1, or 0 if you want it just on the axis. So I'd now like you on your sheet, just down the bottom here, because I didn't leave you a space to do it, I'd like you to write down what your function is going to be. So for the rest of the video, I'll be using y is equal to 3 sine bracket 2 bracket x plus 3, x plus pi on 3 plus 1. Okay, so that's going to be the function that I'm going to be graphing. So now each of you should have a sheet in front of you that looks like this. Once you've stated it in this form, you can start manipulating it over here. So I'm going to first identify all the variables that I'm using in my function. So a is going to be equal to 3, b is going to be equal to 2, c is positive pi on 3, and d is going to be +1, and the type is a sine graph. Now, step 2 is to find the max and the minimum of this function. This is going to define the range for us. So our d value is 1. We're going to add it to the a value, which is going to give me 4. Then for the next part, I'm going to have our d is 1 minus the amplitude, or the distance from the middle of the graph to one of the peaks, and that's going to give me -2. So my range for this thing, the axis that I'm going to have going like that, is going to range from +4 all the way down here to -2. Step 3 is to determine what the period of our function is going to be. So we need to use our formula of 2 pi divided by b. So 2 pi divided by 2. So this thing is going to have a period of 2. Now, one thing that I forgot to write on this page is the domain. So we're all going to have the same domain, and this will be important after. So our domain is going to be from 0 all the way up to 2 pi, and including those values. Now, we're going to end up sketching 3 different graphs all on the same piece of paper. So we want all of our domains to line up on the page. So I'll have one graph going like that, one graph like that, one graph like that. The ranges can all be different, but we want these to all line up. Anywho, so now I've got the periods, I've done all of this. I'm going to go over here and I'm going to fill in this part here. Now, I might have to do some extra bits on the end of either way of the graph that I find here, but this is going to help me identify where the first period is. So for a sine function, it's going to help me identify where this portion of the graph lies. So first thing I'm going to do is our period, pi, times the fraction, minus our c value. So over here, I've got positive pi on 3. Now, if that was negative, I would be minusing negative pi on 3, which would make that positive pi on 3. So currently for this part here, I've worked out that it's going to be, this function begins at minus pi on 3. And because that's a sine function, that's going to represent a mid. Now I'm going to do the same thing for the rest of it. So the next one's going to be pi multiplied by a quarter minus pi on 3. That's going to give me pi on 4 minus pi on 3. If I change this around so that the bases are the same by multiplying this side by 3 and this side by 4, they'll each be over 12, and I'll have 3 pi minus 4 pi, which will give me minus pi on 12. So minus pi on 12. Okay, the next one. So I haven't got anything that's inside of my domain yet, but that's okay. We'll figure that out later. So that's the mid, because this is a positive sine graph. The next one is going to be at the max. So this part here represents a max. Okay, now we're going to look for 50%. So pi times 1 over 2 minus pi on 3, which means I'm going to have pi on 2 minus pi on 3. And that's going to give me, now I'll times this side by 2 and I'll times this side by 3. They'll all be over 6. So I'll have 3 pi minus 2 pi will be 1 pi on 6. So pi on 6, and that's going to represent a mid. Next part we're doing, pi times 3 pi on 4 minus pi on 3. So pi, or 3 pi on 4 minus pi on 3 times this side by 4 times this side by 3. That's going to become 9 pi minus 4 pi, so 5 pi on 12. So 5 pi on 12, and that's going to be a minimum. Okay, next one we're doing is the 100%, so it'll just be pi times 1 minus pi on 3, which is going to give me 2 pi on 3, which will be mid, max, mid, min, mid. Okay, so in the next video, I'll show you how to put this onto a graph. Or, yeah, we'll do it in the next video.